The Bible tells us of a time in which everything that is familiar to us will pass away, and there shall be a new heavens and a new earth. Well, that prophetic vision may well apply to the end of time, but only with a little bit of stretching. It applies to the tremendous changes that occurred in astronomy and physics in the scientific revolution, particularly around the year 1600, when the three characters that we're going to talk about in this lecture all lived. These three characters are first Tycho Brahe, then Johannes Kepler, and finally Galileo Galilei. Let's start with Tycho. Tycho Brahe was born in 1546, so 3 years after the publication of Copernicus's De Rev, if you want to put him in that context. He lived until 1601. Well, he's known as the most precise, and in fact the last of, the naked eye observers, the naked eye astronomical observers. His volumes and volumes of observations provided keys to several important discoveries about the structure of the heavens. Well, who was Tycho? First of all, Tycho was a member of the Danish nobility. If you are familiar with Shakespeare's Hamlet, you may remember the characters of Rosencrantz and Guildenstern. Tycho's actually related to them. As part of the Danish nobility, part of his astronomical program was made possible by a grant that he received from the king. He was given the island of Hven, which is a small island in the Danish Sound, northeast of Copenhagen. Here on this island, Tycho built his observatory castle beginning in 1576. Now, this castle was, in a sense, a multi-purpose center. First of all, as a member of the Danish nobility, he needed a manor house, so it was his manor house. It was also his observatory. There were places to make observations both in the castle and on the grounds. And he also conducted experiments in Paracelsian medicine there, the preparation of Paracelsian medicines, and on alchemical experiments. So he did quite a lot there at Uraniborg, which was the name of his castle. Uraniborg meaning it's a strange combination of Danish and Greek, the castle of the heavens. Tycho carried out observations there for decades, and he was assisted by a large number of students. How did he actually make his observations? Well, he had a large number of very precise instruments made. Remember, this is before the telescope, so it's all naked eye observation. He used things like quadrants. This is a quarter of a circle affixed to a wall. The wall runs exactly, let's say, north-south. There is a line to the meridian. And you can, by moving a sight that's pivoted, measure the altitude of a planet or star as it crosses the meridian. That's one kind of observing tool. This is a little bit more complicated than it sounds. It's not just moving a pivot and reading off a number, because you have to correct for atmospheric refraction. When a ray of starlight enters the Earth's atmosphere, particularly if it's obliquely, it gets refracted. And so the altitude that you actually see it at is actually a false reading. It's a reading after refraction. So Tycho had to correct for the effects of atmospheric refraction, which can be quite substantial, actually. Well, several of the specific observations that Tycho made pointed out certain deficiencies in the Ptolemaic and Aristotelian view of the cosmos. The first one happens in November of 1572. Tycho is busy working out the prognostications for 1573. Remember, we think of Tycho as a naked eye observer, as an astronomer, but of course he was interested in astrological prognostications as well. In November of that year, according to him, he comes out of his laboratory and he looks up and he sees a new star in the constellation of Cassiopeia. A new star? Well, if you're making a prognostication, what does it mean when suddenly a new star appears in the heavens? More importantly, he and others found that this star was further away than the moon, using parallax, in this case using diurnal parallax. That is, you take a measurement, you look at the heavens at a time early in the evening, and then one just before dawn. The Earth has rotated a considerable distance. or the heavens have revolved a considerable distance, depending on your cosmological system. The two situations are observationally equivalent. You can see a parallax of the moon this way. So you observe at two different vantage points and look for change, just like the thumb held at arm's length, looking at it with your two different eyes. This means that there's change in the heavens, contrary to Aristotle. Remember, Aristotle said that the superlunary realm was an eternal realm. It was a realm without change. The same thing happens in a different way in 1577 and 1585. In each of those years, a bright comet appears, and Tycho and others find that it has a smaller parallax than the parallax of the moon. Therefore, it's much further away than the moon is, it's in the heavens, and a change has occurred. Aristotle said that comets were a terrestrial, an atmospheric phenomenon. They were the ignition of vapors coming up from the Earth. But Tycho and other astronomers in late 16th century show that the comets are much further away. Tycho also finds that the path of the comet had to take it through the sphere of Mars, meaning that the planetary spheres cannot be solid objects. Because here's an example of an object that has crossed from one side of the sphere of Mars to the next. Well, there are the ways that Tycho presented information that was at variance with with Ptolemy and Aristotle. Did he adopt Copernicus? Well, remember, very, very few people adopted Copernicus. Tycho was not one of them. He rejected heliocentrism. He rejected the idea of a moving Earth as physically absurd and theologically untenable. It's theologically untenable because if you'll remember in the Old Testament, during a battle, Joshua, through the action of God, makes the sun stand still. And it says, "Stand thou still, O sun." It doesn't say, "Stand still, O earth." The sun is stopped by Joshua. Therefore, the sun must be the thing that's in motion, not the earth. So Tycho, taking a literalist stance, thinks that Copernicus is theologically untenable. In 1588, however, Tycho presents his own solution, a solution to the structure of the cosmos that follows neither Ptolemy nor Copernicus. He retains the Earth at the center, immobile. The moon goes around the Earth. The sun, likewise, goes around the Earth. But all the other planets have the sun as their center of motion. So there are two centers of motion in the Tychonic system, whereas there's only one in Ptolemy. There are actually two in Copernicus because the moon goes around the Earth as well. But for Tycho, all the planets orbit the sun, but the sun orbits the Earth, as does the moon. Now we have three systems to choose from: Ptolemaic, Copernican, and Tychonian.